Welcome to qnawire.
Okay, so we know speed of sound in the air can be expressed as a square root kRT. We know the specific heat ratio for the air is 1.4, and the gas constant for the air is 0.287 kilojoule per kilogram times Kelvin, which is 287 joule per kilogram times Kelvin. So for the first case, we know the temperature is 300 Kelvin. So now let's plug in back to the equation to determine the speed of sound in the air, which is equal to 1.4 times 287 joule per kilogram times Kelvin, and then times the temperature, which is 300 Kelvin. And this will give us the speed of sound in the air is about 347 point, you know what, let's round it down to the single digits, so it's just 347 meter per second. So therefore the Mach number for this case should be equal to V over C. V is the velocity of an aircraft, and we know C is the speed of sound in the air. So therefore, let's use the data to determine the Mach number, which is 330 meter per second over 347 meter per second, and this will give us the Mach number is about 0.95. And for the next case, we know the temperature is 800 Kelvin. So now let's plug in back to the equation to determine the speed of sound in air in this case, which is equal to 1.4 times 287 joule per kilogram times Kelvin, and then times the temperature, which is 800 Kelvin. And this will give us the speed of sound in the air is about 567 meter per second. So now let's determine the Mach number, which is V over C, which is 330 meter per second over 567 meter per second. And this will give us the Mach number in this case is about 0.582. And these are the answers for this question.